Hello, everyone. This is Gang He. I'm an assistant professor in the School of Public and International Affairs at Brooke College, City University of New York. Unfortunately, I cannot make it in person, but I appreciate the opportunity to share my topic with you that I'm very excited to introduce Switch China, a model to the transition of the world's largest power sector. China's power sector is really massive, as you can imagine, but it's not just about the size or the scale. There are many questions that we can use the model to help us to understand. China's power sector consumes about a quarter of the world total coal consumption annually. At the same time, China also accounts for 40% of global solar wind capacity. So these two happens parallel, right? And no need to say about 1/8 of the global carbon emission in this one single sector. China's power sector is on very fast transition, and its future has a lot of uncertainties. And this is why a high spatial resolution and a temporal resolution model will be needed consider the impact of a renewable energy dominant future power system. And to model it, we have a lot of challenges. One central is the data. There are three data challenges. First is all the data needed for a high resolution model really available. And if even it's available, there are accessibility challenges. And even we get those data, can we trust it, right? This is the credibility challenges. And all in all, to help us to understand such a massive sector, we need transparency, and so we can compare with other model teams and the results to help us to understand this sector. So that's where Switch China come in. And this is our first paper back in 2016. And since then, we have keep updating, improving, and publishing new findings. And the structure of the Switch China model is no major difference than other models, but I want to highlight a few things. First is data. We have put a lot of efforts to work with our collaborators, with our contacts to improve the data of China. This including generation, transmission, demand, costs, and policy databases. In addition to data, there are also the China-related modules that, in addition to building on the wonderful switch model that adapt to China's energy policies and the priorities. Those include plans, those technological goals and limits. As you can imagine, China's power sector is heavily influenced by the central government and the local government plans, including wind, solar, offshore wind development plans, and coal control goals. One other area is the energy water nexus and integration with multiple sectors. That's where the electricity, carbon, water Lexus come in. We also emphasize some other emergent technologies, for example, storage, pumped hydro, offshore wind, and increasingly hydrogen. I want to highlight a few papers in those lines. One is a paper collaboration with Lawrence Berkeley National Laboratory publishing Nature Communications. We investigated how low cost of renewables can reshape China's power sector, which is not well discussed in the previous literature. And we found if the cost trends continue the past decades trends, by 2030, China can have more than 60% of its electricity come from non-fossil sources as compared to about 50 in the previous discussion. This shows transition to a renewable dominant power system is not just technical feasible, but also economic viable. One of the paper on the energy water Lexus theme is we studied the water implications to the adaptation of carbon capture and sequestration. So with low cost renewables reliability, the reliance on coal CCS will be reduced by 80%. If we add water constraints into the discussion, then it's almost completely rule out the usage of CCS in achieving carbon neutrality. Instead, most rely on the expansion of renewables. So that means if we move towards decarbonization, carbon is for sure a very effective policy tool. At the same time, if we consider water implications or water resources, that will further accelerate the transition. There are some other policy questions. This work led by Dr. Li Chunpeng. I'm sure she will share more in her lightning talk. So what switch can do? Conventionally, we can use such models to study the capacity generation mix and impact of costs and technologies, and to model policies and regulations. But in addition to that, the model can integrate with other models, for example, transportation models. So we can study the integration of a power system and the transport system, and integration with building models, and work with air quality and the human health models to study the air pollution and human health co-benefits of our power system transition, to work with input-output models to study the economic and employment impact of a different power system transition scenarios. So that's a brief introduction of Switch China, its data and its new capabilities. And we fully open source our data and model and the resources related to our papers. I also created Chinese language instructions. So if you need data or you want to know more about our work, please feel free to scan this code to access the online open repository. We very welcome collaborations and contributions. You can help us to spread the word, and you can also use our data and same time share any localized data that you may aware of, and we welcome new collaborations. This work is built on many collaborators' contribution. I won't read all the names here, but this is really an effort of teamwork and built on many years of collaboration. I want to thank all my collaborators. Some of them might be here. A little bit, if you are interested in more about my work, here's my research in mind map. I also want to take 1 minute to share the energy systems analysis class that I open sourced. I hope that can provide some resources for our teaching and to help educate next generations of energy modelers. So with that, I just stop here. Here's my contact, and welcome. Please reach out if you have any questions or any ideas of collaboration, and I look forward to working together with you. Thank you.